We will now determine the absolute maximum and minimum points of this given function. F of x is given as x cubed minus 9x squared plus 15x within the interval 0, comma 4, and both 0 and 4 are included. That is, 0 and 4 are the endpoints. So basically, this involves three steps. The first step will be determining the critical points. Remember that critical points are obtained when the first derivative equals 0. That is, we have to find f prime of x and set it up equal to 0. So that will be our first step. And in the second step, we'll be determining the relative maximum or the relative minimum points, or it's also called as local maximum or local minimum points. So this we will find out by creating a sign chart for the first derivative of f of x. So then finally, in the third step, we will determine the absolute maximum and minimum points. So let's do the first step, that is determining the critical points. For this, we have to find the f prime of x. So first, let me copy the function, that is f of x equals x cubed minus of 9x squared plus 15x, and this is within the interval 0, comma 4. So I'm going to find the derivative on both sides. The derivative of f of x is f prime of x, and this equals, we have to find the derivative of each term by applying the power rule of differentiation. So when we do that, derivative of x cube is 3x squared minus derivative of 9x squared. 9 is a constant, so we apply the constant multiple rule and find the derivative of only the x squared. Derivative of x squared is 2x plus once again we apply the constant multiple rule, since we have a 15 as a constant, and we find the derivative of x. Derivative of x is just 1. So let's simplify this. This becomes 3x squared minus of 9 times of 2x is 18x plus 15. So this is our f prime of x, that is the first derivative of the function f of x. Now we have to set this up equal to 0 and find the x values. Those values of x are the critical points. So let's do that. We have to set up f prime of x equals 0. And this means this will become 0 equals 3x squared minus of 18x plus 15. We see that the right side expression, we have a common factor of 3. So we can divide both sides by the common factor 3. So I do that. 0 divided by 3 is 0. And this equals x squared. 3x squared divided by 3 is x squared. Minus of 18x over 3 is 6x plus 15 divided by 3 is 5. So basically we get this equation. I rewrite this equation as x squared minus 6x plus 5 equals 0. Now this could be factored into product terms. That is, we can factor this as product of two terms as x minus 5 times of x minus 1 equals 0. And then we solve for x. So therefore, either x minus 5 equals 0 or x minus 1 equal to 0. And this gives 2 points, that is x equal to 5 as well as x equal to 1. But notice that x equal to 5, this point does not lie within the interval, that is a given interval 0, comma 4. So we can ignore this point for this problem, and we consider the another point, that is x equal to 1, and this lies within the interval 0, comma 1. So basically we take only this point as the critical point of this function. We will now do the second step, that is we have to determine the relative or local maximum or minimum points. For this, we have to create the sign chart for f prime of x, that is the first derivative of x at the critical point x equal to 1. First, I'm going to rewrite the f prime of x in factor form. That is, the f prime of x we have is 3x squared minus 18x plus 15. And I'm going to rewrite this by factoring 3 and writing as a product terms. That is, when I factor 3, I get x squared minus 6x plus 5. And this, in fact, can be factored into product terms. So therefore, we can rewrite this as f prime of x equals 3 times of x minus 5 times of x minus 1. So basically, we will utilize this form of this f prime of x to make the substitutions. So first let's create a sign chart for the f prime of x at the critical point. So I have this critical point at x equal to 1. Basically, I have to understand the sign of the first derivative to the left of x equal to 1 and to the right of x equal to 1. So I can take any random values for around this interval, that is if x is less than 1, I can take even 0 and substitute into this f prime of x to determine its sign. So let's do that. I'm going to take x equal to 0. So let me copy it here. We have f prime of x equals 3 times of x minus 5 times of x minus 1. So when we replace x by 0, we get 3 times of 0 minus 5 times of 0 minus 1. Basically, we just have to determine the sign. We don't have to calculate completely. So this is 3 times of negative 5 times of negative 1. So negative number times of negative number is a positive. And finally, we have this 3. So it's going to be positive quantity. So it's basically positive to the left of x equal to 1. And now, in the same way, we will take another point, some temporary random points to the right of x equal to 1. So I'm going to take x equal to 2 and replace into the f prime of x. So therefore, this becomes 3 times of, when I replace x by 2, this becomes 2 minus 5, and this becomes 2 minus 1. So therefore, finally, we get 2 minus 5 is a negative number, negative 3, and 2 minus 1 is a positive number, it's a positive 1. So we get a product of negative and positive, which is basically a negative number. So the sign of this f prime of x after, to the right of x equal to 1 is negative. So now we have created the sign chart. So it's basically the derivative is positive to the left of x equal to 1. At x equal to 1, it is 0. And then after x equal to 1, that is to the right of x equal to 1, it is negative. So when we plot this in the graph, it will look like this. So it's basically this point. This is a point of maximum. At x equal to 1, it's a point of maximum. So we say this as relative maximum, relative or local maximum. So maximum point. Let's do the final step. That is, we have to determine the absolute maximum and minimum points of the function within the interval 0, comma 4. So I'm going to create a table of values for the endpoints as well as the relative, as well as the critical number, and then find the corresponding f of x. So first, let me copy the function f of x. F of x equals x cubed minus 9x squared plus 15x, 9x squared plus 15x, and this is in the given interval 0 comma 4, and both are included. So we can create and also we have determined that at x equal to 1 we have a relative maximum. This could also be a possible absolute maximum. We will determine this after creating this table. So I create the table for x versus f of x. This is x and this is f of x. So we put the endpoints as well, 0, and the critical point, that is 1, and then the endpoint we have 4. So these are the points which could be possible absolute maximum or minimum. We already determined that at this point we have a relative maximum. We'll find the corresponding function value. So when we replace x equal to 0 into this equation f of x, we get 0 cube. Since we have 0 in all the terms, this is basically going to get us 0. So this is 0 comma 0. And then we have to replace x equal to 1 into f of x. So when we do that, we get 1 cube minus of 9 times of 1 squared plus 15 times of 1. So this gives 1 minus 9 plus 15. So this is negative 8 plus 15 is positive 7. So I put 7 over here. and then we have to replace x by 4. So therefore I can write down here 4 cube minus of 9 times of 4 squared plus 15 times of 4, and we can simplify this using the calculator, and when we do that we get the value negative 20. So let me put this as negative 20. So now we have to look into the table and determine the lowest function value. The lowest is the negative 20. So therefore, this point 4 comma negative 20 is the absolute minimum point. So we write down absolute. This is the absolute minimum. 4 comma negative 20 is the absolute minimum, and if you look at this table, 7 is the maximum value. So therefore we take this point 1 comma 7, or we consider this as the absolute maximum of the given function within the interval 0 comma 4. So we write down this as absolute maximum point. This equals 1 comma 7. So these are the absolute maximum and absolute minimum points of this function.